PCAD, or the Propulsion and Cryogenic Advanced Development Project, is developing rocket engine and propulsion technologies in support of the U.S. space exploration policy. The PCAD team is testing and evaluating high-performance cryogenic propellants and propulsion systems that can launch, maneuver, and land the various components of Project Constellation, NASA's new generation of manned spacecraft. The main objective of the PCAD project is to develop the technologies for propulsion systems of new, more powerful rocket engines using higher-performing cryogenic propellants or combinations of propellants such as liquid methane or liquid hydrogen with a liquid oxygen oxidizer. The multi-center PCAD team capitalizes on the strengths of each NASA center member. NASA's John Glenn Research Center leads the project in partnership with Marshall Space Flight Center, Johnson Space Center, and White Sands Test Facility. The cryogenic propellant combinations being investigated by the PCAD propulsion team have the potential to provide significant performance increases over the hypergolic propellants used on the Apollo missions, providing more specific impulse or thrust per pound of propellant mass flow. Reducing propellant mass lowers total vehicle weight. This can possibly reduce the vehicle size or allow additional crew or cargo to be delivered to the lunar surface. Cryogenic propellants are abundant here on Earth and are thought to be available on the Moon and on Mars. Astronauts may have the ability to extract and produce the propellants for their return trip at the landing site, utilizing an in-situ resource utilization process. PCAD is currently conducting advanced technology development and testing of propulsion options which could find their way onto the Altair lunar lander. The three types of engines are the reaction control engine system, the descent main engine, and the ascent main engine. The PCAD project is focused on reducing the risk of implementing a new propulsion system. For cryogenic propellants, some of the primary focus areas are reliable ignition in a space environment and engine performance. The Reaction Control Engine System, or RCS, controls the attitude of a space vehicle in flight. These engines must operate thousands of times, in short bursts or for long durations, to steer the vehicle, or in case of emergency. Keeping astronauts safe is a major concern. A safe, reliable ignition system is key to the successful implementation of cryogenic propellants. Ignition must occur in an instant while being exposed to the extreme temperatures in space and at varying propellant temperatures, pressures, and oxidizer-to-fuel ratios. The lunar lander needs engines that are responsive and quick to ignite, both during initial descent and in launching from the lunar surface. The PCAD team is testing a number of ignition concepts, including spark torch, microwave, and catalytic igniters. These concepts will be demonstrated with ground tests to show that they can perform over the range of conditions required to complete all vehicle maneuvers during the mission and to ensure crew safety. To deliver significant payloads to the lunar surface, the descent main engine will use one of the highest performing propellant combinations available, liquid hydrogen, liquid oxygen. When landing on the Moon, astronauts need to be able to throttle and control the lander's descent main engine to provide a soft landing, or, if obstacles are encountered, to maneuver to a different landing site. To meet this requirement, the PCAD team is focused on demonstrating stable combustion with the required performance at low power levels. Understanding engine performance during throttling will help determine how much propellant is needed and will help lower overall vehicle weight. The descent main engine concept is designed to throttle down to as low as 10% thrust or 10-to-1 throttling. A cryogenic propulsion engine that could propel the lunar lander off the Moon's surface after the completion of the lunar mission is also being developed and tested. NASA is currently investigating a 5,500-pound thrust engine that uses liquid oxygen and liquid methane propellants. The current concept engine uses a high-temperature ablative material to cool the combustion chamber. The PCAD team will be evaluating the engine concept with a series of tests at both sea level and vacuum conditions. Initial tests with the previous lunar ascent engine, the RS-18, at vacuum conditions have demonstrated the ability to ignite a liquid oxygen methane engine. PCAD develops innovative propulsion technologies and components to meet mission requirements. The team designs and conducts tests to evaluate the components over a wide operating range. Testing the limits helps researchers understand how far the hardware can be pushed. The data and performance envelopes PCAD provides to the vehicle development teams are used to evaluate and develop lander design options. Data from PCAD is key to developing the next lunar lander.